Okay, well, welcome everyone to our second lecture in our series of seminars that we dub the Expeditions in Experiential AI. This series of talks is provided by faculty at the university at Northeastern, and is targeted really to kind of share information publicly, worldwide, etc. So we welcome anyone to attend if you register. Today's second lecture is going to feature Ricardo Baeza-Yates. Ricardo and I go way back. In fact, I met him in the first time in the Southern Hemisphere, and later on he ended up running the research labs, the Yahoo research labs for us in Latin America and in Europe. And he grew a big lab in Chile, and then a bigger lab in Barcelona, and then other places in Europe. Ricardo is well known for many things in search, in information retrieval. In fact, his book on modern information retrieval is considered kind of one of the Bibles. Some will say the Bible on IR. He has also, over the past few years, managed to evolve his areas of interest to include ethical AI, responsible AI, and kind of identifying different forms of bias, and which sometimes can get very tricky in applications of artificial intelligence, an area that's becoming extremely important. This is the second time I have the honor and the privilege to work with Ricardo. So the first time was Yahoo Research. This time is in the context of our Institute for Experiential AI at Northeastern University, where Ricardo serves the role of Director of Research and is responsible for kind of growing our research arm through postdocs, research scientists, research faculty, and so forth. With that introduction, I leave you in his very capable hands. Ricardo will be talking to us about ethics in AI and how challenging that task is, much more than it appears on the surface. And of course, in a rare moment celebrating the end of the pandemic, we are both together, not physically distancing, not wearing masks, but sitting at the campus of the Roux Institute of the Northeastern University.
And both fully vaccinated.
Yes, we are definitely both fully vaccinated. So over to you, Ricardo, and thank you for doing this lecture for us.
So thanks to Sama for the kind introduction, and I will start right away with the presentation. So the first important thing when you talk about ethics in AI is that ethics is a human thing. So we are extending this to machines in a way that may be not the right way, but we talk about that. So let's talk about ethics in AI. And before that, let's talk a little bit about this new institute that Usama is heading, that started only end of last year. And basically, like Northeastern University, that was the creator of the co-op experience, like you work every year in your undergrad, the same is happening here in this institute. We want to find what is practical, what it works, and for example, two things that we find important on how things work is to have a human in the loop. I will get back to that in the talk. Basically, having the common sense, the experience, the knowledge, to basically find the right way to use AI. And also the strong dependence on data, when many times we don't improve the algorithms, we just get more data. And sometimes more data is not the answer. We also will mention that in part of the presentation. So the agenda has two parts. The first part will be about current ethical issues that are like my own bias here. So as Osama said, I have worked a lot on bias, like more than 10 years, even before bias was trendy. And I want to cover these 5 different kinds of problems, like basically it's automated discrimination, what is physiognomy based on facial biometrics, but also in other biometrics, and fair digital commerce, basically the stupidity of models, and then something about if we're using the resources well. The second part, I want to go to more generic issues, like we have too many principles, how we solve them. This is ongoing work that I'm doing. Also about cultural differences, regulation, very important, all the legal aspect. At the end, I will end with the cognitive biases, but then I will try to have the more pragmatic, experiential part, what we can do after we learn all these things. So the first problem, of course, is bias. I call it the course of bias. All algorithms receive biased data. In some sense, information is biased. Otherwise, if you have like a random noise, the algorithm will not be able to do anything. And one first question is, should the algorithm be neutral? Should the algorithm be fair? Already defining what it means to be neutral means to be fair is hard because, for example, regarding fairness, most definitions of fairness are not aligned. So it's very hard to fulfill 2 fairness conditions at the same time. So most of the time, the algorithms don't answer this question, and then you get the same bias, and worse, sometimes you get amplified bias. So the first examples will be how to get to this amplified bias, because if we have amplified bias, that means that bias is not only in the data, as many very relevant people say. So some biases come also from the algorithms, and there are even more. We will see that also the biases come from the interaction of users and the systems. So just to remember, we can have equality, not always works. We have equity, so we achieve equity with affirmative actions. You can see that these are positive biases. And then you have, for example, everything related to justice, where you really get rid of the problem, but that takes much longer, and we are seeing that with some social biases that are today still important in our society. So if you want to learn more about this, I recommend this movie done mainly by women, Coded Bias, and also we had a very interesting panel in the ACM, where I was lucky to participate in March with the former president of ACM, Wendy Hall, a federal judge, Latana Sweeney, which invented the K-anonymity, and all this chaired by Gina Matthews, which is a person that also has worked on this topic. So let's go back to the question, this non-technical question. It's a question that is not computer science that should answer, it's society that should answer. So this is a very, very important thing. Sometimes we answer questions that are not for us, that we are not the experts on these questions. And of course, the answer is not always you need to answer these questions, but if you harm people, physically, psychologically, and we'll get back to that, then you need to answer this question. And how do we can mitigate the problem? Well, we can debias the input, we can tune the algorithm. For example, in search, we have learning to rank with bias, ranking bias, or we can debias the output. All of them have different complexity, and also some of them are better or worse, depending on the data. And of course, when you do it in the output, you already lost information, so not always you can achieve what you want. So let me start with one classical example that's maybe the most used example, because one of the earliest examples, already 5 years old, is what happened with Compass, a software for criminal profiling. And this was created as a support tool, not as a decision tool, but some people were using it as a decision tool. And also we know that humans are influenced by recommendations coming from algorithms, and then they tend to believe them. And for example, ProPublica found that there was a clear racial bias on this criminal profiling. This was a lot of discussion, a lot of analysis, also different people saying there was no real racial bias, and I'd say that even there was more, depending on how you look at this data. But then there are two important questions in this example. The first one, is a secret algorithm ethical? So if we have a societal problem, do we want full transparency? And most people will say yes. But then we need to remember there's another important question is a public algorithm safe? Because then you can game the algorithm. And for example, if this is a criminal profiler, you may learn how to look like you are a fine person. But this has been used in other contexts, not only on the context of prison, which was the context of Compass, but you have things, for example, Godam, a software by Palantir, where basically this was used for real criminal profiling, not after you are in prison, but even before. And this was complicated because, for example, Los Angeles was bought by the police foundation, so no one needed to know. In New York, was never approved by the council of the city. In New Orleans, they kept it secret until someone, basically a whistleblower, put it in the news, and so on. Even in some countries in Europe, if they are using this system. And the problem here is not if it works. We can argue if it works or not, maybe 80%, 90% may be great. The problem is what happens in that 10% where it doesn't work. One error, and the life of a person will change forever. So there are other examples. For example, here is one from Spain, where you have not something that is to check the people accused to do something, but the victims. So this is to check if the victims are saying the truth or not. So it's like a lie detector. And had many problems because this was not directly on what the person was saying, but was by using the text of what the police wrote that the person said. So that's already a problem because it's not a direct transcript of what that person said. And this, for example, basically this is still being used by the police, but when in Germany they tried to do something similar, the Pirate Party immediately challenged in a EU court, saying that this was not fulfilling the human rights of the EU. So you see two different approaches from the civil society to the same kind of software. So let me give you an example, detailed example of how bias can be amplified. And I think this is my favorite example, is based in New York. So basically here you have the flow of how things happen. So you have an offender, the judge have to decide if you get bail or not. So typically in most of the world, the judge has to think if you are reoffending, if you are out, and if you will appear in court later. Well, in New York, you only have to answer the question of, the judge only has to think if the person will appear in court or not. Doesn't matter what kind of a crime you are accused to do of. So this is the first kind of special thing. And then, of course, if you get bail and you can pay, you go away. If you cannot pay, then you go to prison. But for example, in the US, there are people that from where you can borrow money to pay bails, and I guess they know each other, and they have to do the same prediction of the judge. So will this person appear in court and pay the money back, of course, with some interest? And then if you don't get bail, you go to prison. So the one problem here, like in many other problems, we don't know all the data. For example, we don't know what would have happened if the person get bail and, for example, will not reoffend or will not appear in court. So to fulfill this missing data, we need to do data imputation, and then that means that these kind of models are more complicated than other standard predictive models. So what were the results? And this was some work done for the National Bureau of Economic Research of the US, not for the National Justice Department, because judges are not interested in this, I guess. But of course, the US government wants to spend less money in prisons. So the model, if the model is correct, remember this is a prediction, this is a model, the model can be mistaken, but basically the model says that they could decrease crime rate in 25% according to the data, or decrease the prison rate in 42%, keeping the same crime rate. So it depends on what you want to keep. So the model was much better than the judges. And I will go fast because I have a lot of material, but this set was, the data set was split in 5 parts. One to do the imputation, one was locked in a box, so anyone can basically verify the results with data that the model has never seen. So they use gradient boosted decision trees. So these are like decision trees, but they have a degree of nonlinearity, and that allows some interpretability. And the only demographic variable was the age of the person. All the rest was basically just the case. So there is no variable where you can learn anything related to race, like, for example, address that is correlated with race. Well, these are the results of the model. Here you see basically the defendants is almost 49% black, 33% Hispanic, in total 82%. And here I put in red the actual percentage of that population in the state of New York. So they are only 32%. So it's already a bias on what police brings to the court. So it's more than double, from 32% to 82%. And the judge, clearly the judges are a bit racist, because the percentage of black goes from 49% to 57%, so it's an increase there. And it lowers a little bit in Hispanic. So what about the model? Well, the model learned from the data to be even more racist. So here went from 57% to almost 60%. Also learned to be less racist to Latino population, and then went down to 30%, but overall they still increased to 90% from 89%. So this in general was more racist. If we use the base rate of the best judge, so the less racist judge, then still we can improve the system by 23%, basically dropping the crime rate and keeping the same number of people in prison. So here we have the first dilemma, because why this is happening? Well, if taken from the paper, so this figure says if the model is right and you want to send additional people to prison, then you take people from the top of the risk category. But if you see what one of the group of judges does, in this case the second leniency quintile, then you see that they're taking people from all over the risk according to the model. So if the model is right, the judges are almost doing random choices on this. So why is that happening? Well, that's happening because human decisions have noise. So the dilemma is, what is better? A biased algorithm that is just in the sense that for the same 2 cases you get the same sentence, bail or not bail, or a noisy judge. And in reality, it's not a noisy judge, it's a noisy racist judge. And here you see the 4 different cases of something being exact, just noisy, just biased, or biased and noisy. So algorithms are biased, but judges are here, biased and noisy. So it could be even worse. And this appears in a paper on Harvard Business Review in 2016, and I have been talking about noise after that. But good luck, last month, Daniel Kahneman, with colleagues, Nobel of Economy, published a book on noise. I'm reading it now, with other examples where basically human decisions may have a cost that is even larger than say, biased decisions. So just quickly to other examples of bias. So you have issues of gender, and you see here many different companies. Maybe facial recognition system is the one that has been in the spotlight, like in the Coded Bias movie. And it's very interesting because if you see how facial recognition has been developed, work has been developed with many data collections that have been growing exponentially. So you see here that the y-axis is a logarithmic. So basically, in time from 1990 to today, the size of these collections have grown exponentially. And if you check how this data has been recollected, you see that in the last two periods, so basically after 2007, if you see the lines here, most of these faces come from the web. And that means that they have no consent. So the person didn't consent on using his or her face for this purpose. So in some sense, there is an ethical problem all the way in the developing of this technology. And for all the mistakes on, for example, especially black faces, the top companies selling this kind of software decided to stop selling to basically to law enforcement this kind of software. Here we have Amazon, Microsoft, and IBM. If you see the Coded Bias movie, these companies have a completely different reaction to the fact that they were doing mistakes. But still, this was used, and ACM in 1 year ago asked for a suspension of using this technology. I was part of the committee that signed this statement asking for this. But the software was already there. The police bought the software before. And for example, in September, we had the second case, well-known case, of a black man accused wrongly of doing something because of a mistake of the technology. And very interesting, there's a paper also of last year that shows that it's impossible to get consent for facial surveillance. So we have a problem, and we'll get back to that. In particular, in the US, several cities have forbidden the use of facial surveillance, like Oakland, San Francisco, some cities in Massachusetts, and so on, have forbid this kind of technology. We have examples in gender bias in language translation. For example, here, this is something that has been fixed by Google end of last year. But if I say he's a babysitter, she's a doctor, I translate it to Turkish, I do the translation back, I get the opposite genders. But if you try today, you get only female ones. If you do just one sentence, you will get the two possibilities, the two binary possibilities, which is also something that we know is not correct. But here we get even she's a doctor with a capital S. Maybe this is a artifact of using things like BERT in these models. Then the same in information extraction. Here you have a classical example from NeurIPS 2016, where you see that basically most of she-he analogies have a gender stereotype. Like diva has a bit of negative connotation, but superstar doesn't in the case of a man. So I also did some research on why this is happening, and it's more than systemic bias. It's because also most famous journalists in the US are men, but this is not the case in colleges. So there's another bias here. It's very hard for a woman to get a good job as a journalist in the US. So another example from Stanford, word embeddings that basically also have stereotypes in this case for professions. So you see that the janitor is Hispanic, the secretary is Asian, and for example, the administrator is white. Language models. This has been on the news several times. So here I'm using a table from a paper I will discuss a little bit later. But you see how these things have grown in the number of parameters from hundreds of millions to basically 1.6 trillion, and recently there was a Chinese one of 1.7 trillion parameters. If you think about that, that's getting close to the number of words that you are using to train this model. So at some point you will overfit. And what is the problem with this? Well, you learn all the biases encoded in the text. For example, here is a paper that was published last January that shows that you have anti-Muslim bias. For example, if you write this sentence, two Muslims walked into A, and then you ask GPT-3 to complete this, most completions will be violent. For example, we'll start shooting at will or open fire and so on. And they look at all religions, and basically for Muslims, it was 4 more times violent completion than for Christians. And it's interesting to see that the less violence in the news, at least, are the atheists and the Buddhists. So maybe religion is part of the problem. But it can be much more complicated. So, for example, there have been complaints about ads. There have been complaints last year about, for example, grades to enter the university, where the government thought that they was doing something nice, avoiding students giving an exam on time of the COVID, but basically just amplified the inequalities already existed in the system. And this went into the news, and basically at the end they didn't use it. Or it could be even more complicated, like this interesting case in Italy that was settled in January of this year, where Deliveroo, which is a platform to deliver food to people, was found that they were doing indirect discrimination because it was giving less work to people that couldn't deliver at dinner time. So, dinner time is where you have most demand for delivering food, and the algorithm learned that to sell more, well, you should give more jobs to the people that could do that and not to the people that couldn't do that, without balancing that in other times of the day. And this was the problem, because the algorithm didn't check the reasons that those persons didn't deliver food at that time. For example, they need to feed their kids, they need to feed an old person, or even they don't want to work at night. These are valid reasons not to work. So this was very important. And also, even more recently, in April, a Dutch court basically said that 6 drivers that were fired for accusation of fraud had to be reinstated by Uber in different places. Some were in London, some in Lisbon, and so on. And the interesting thing here is that Uber decided not to go to court because, for example, they were asking for the code. Like the Deliveroo case, they asked for the code, and they gave the code, and then they found that there was this discrimination. Uber, I guess, decided not to go because they didn't want to share the code of this fraud detection application, which is very interesting. They were fined still $150,000 for firing these people for several months that they couldn't work because of this. But it can be really, really bad, even worse than these cases. And the worst example, I think, is what happened in the Netherlands with child care benefits, that after several years, not only the ministry that did that had to resign, the whole government had to resign, because 26,000 families were affected by basically telling them that they were cheating on child care subsidies, and they had to basically return the money. Some people had economical stress, other people have psychological stress, other people had to go back to their native countries, many were immigrants, and this is a case where technology is affecting the vulnerable people, poor people, immigrants, and it's another example where technology benefits the rich people, but you have the poor people suffering it. So, of course, again, there was no intention of this to happen. But there are so many questions that no one was asking, they were not asking here, to avoid this, to get to a whole government resigning. So let's go to the second issue in order of, for me, of importance. This is what is called physiognomy. So physiognomy is a pseudoscience that started with the Greeks and was very popular in the 18th and 19th century, but now it's coming again. For example, Kosinski in Stanford had this predictive model of sexual orientation in 2017. Of course, LGBT groups were not happy at all. Is this ethical? Of course not. Then in China and later in the US, some people trying to use facial recognition to basically do, again, criminal profiling. And of course, this had very bad press. Kosinski strikes back on this January, for example, to say that they could predict 70% political orientation. Most probably is predicting spurious correlations, but of course will not work for everyone. And it's not really facial recognition, it's facial biometric, because you're not trying to recognize any person in particular. So this is a particular case of phrenology that was very popular in the 19th century. In fact, if you go ever to Torino, I would recommend to go to the former house of the Dr. Cesare Lombroso, which was one of the people leading in Italy this belief that, for example, you have a different skull if you were a criminal. And he collected hundreds of skulls, of course, of poor people that were in the morgue and no one went to pick them up. But at least he was consistent with his belief, because he left also his skeleton. I guess this was his ground truth for a nice person, a person that collected hundreds of skulls. But it can be worse. This is a paper, now not from Stanford, but from MIT, that it was published in 2019, that claims that given your voice, you can get your face. I may be able to believe that your voice defines a bit the shape of your mouth and maybe the neck, but what about your eyes, your hair, and so on? There is no causality. But some people believe this causality exists. So I can have now my master phrenology algorithm that basically you give me your voice, I predict your face, and there's another work, it's a file patent by Mirror, that claims that from your face I can get your name. Of course, this will not work with all adopted kids from other ethnias in the world, especially developed countries. So I can use all these things to profile you and then do something with it. And the problem is that these profiles, in some cases, are illegal. So very dangerous if you start believing this. The second kind of issues, unfair e-commerce. And this has to do with the filter bubble. So I may know Osama for a long time, but I will never be able to offer him something new that he will like, because it's not in the data, because it's new for him. So search engines and recommender systems are using things like diversity, novelty, serendipity to break this filter bubble issue, but still this is difficult to break it completely. That's why correlative filtering exists. And for example, some people claim in this case in the past that Amazon was racist on the recommendations. But this is more dangerous. The danger is the feedback loop, which is the third source of bias. It's not the model, it's not the data, it's the interaction with the system. And why is that? Because it's like an iceberg, a big iceberg, that you have exposure bias. You don't see everything, you see only the recommendation that the system is giving to you. And these recommendations are being written by the system, so the system is partly writing its own future. So the data is not independent of the system. And it's worse than iceberg because you are only looking at the top of the iceberg, the ice cube on top of the iceberg, because you are seeing three things of maybe thousands of things. So it's much worse than an iceberg. And you get this problem of the Matthew effect, so the rich get richer and the poor get poorer, and then you get popularity bias that will affect the long tail of items and the long tail of sellers and the long tail of users. And as usual, the long tail will be discriminated. Fourth problem, stupid models. So models that cannot deal with ambiguous semantics, or models that cannot deal with irrational behavior. And here I have this quote from George Box, that all models are wrong, but some are useful. Well, this is true. This was for statistics. This is true in AI too. All models are wrong. All models are simplification of reality, but some are useful. And examples of these kind of stupid models. Elon Musk said, use Signal, and then these systems that work on the New York Trade Exchange pick up this, because they use Twitter data, and they think that it's talking about buying stock of this medical company in Texas. It's called Signal Advance, which is the closest name to Signal. Of course, that was not true, but the company grew their value in more than 400%. Then went down when people discovered the error, but it still had a benefit. But things can be even more stupid. For example, this is a hate prediction example where Facebook basically deleted the page, the website, the Facebook page of a French town that is called Bitche. So you can imagine why the models thought that that was a problem. But also, it had this page 3 weeks without internet because there was no human in the loop to basically receive a complaint from the town, from the mayor of the town, and check if something was wrong or not. A clear mistake. And this is related to adversarial AI. For example, here you have another example from Japanese researchers where if you change one bit of an image, then you get a different label. For example, a cat becomes a bird, a deer becomes an airplane, a sheep becomes an airplane, the cat becomes a dog, and so on. So you ask what these things are learning. Surely they are not learning what we understand by, for example, an animal. And these are the limitations. We need to be to realize that these models have a lot of limitations. For example, it's very hard to forget and filter what you learn. I recommend to read this amazing story by Jorge Luis Borges, which is a Funes de Momoris, a person that couldn't forget and then had to tell you everything that did. But sometimes it's not in the data. Like, for example, if you see this picture, you may guess what is the animal, but the system, AI system, will be very hard to do it because you cannot learn what's not in the data. And there is no such thing as I have all possible examples in the data. Why? Because some samples are from the future. So you cannot have a collection that will include all possible examples that you need to match. And as I said before, for me, accuracy is not the main issue, it's the impact of errors. Because, for example, in medicine, false negatives are worse than false positives, like detecting an illness. And many errors are not human. So if you see some mistakes done by GPT-3, you will see that no person will write that sentence. So those are the ones that have large negative impact when they are negative. In some cases, they're just funny because they don't make any sense. But these are the bad errors, the non-human errors. And we need to be humble then. So for example, if you have a classification system, maybe you need to say, I don't know, when you are not sure of what you are seeing, like an animal. And the last issue is the waste of resources. So I get back to this table from Bender and Gebru et al. And this is a paper that shows that, for example, one issue is that you are training these very large examples. You are basically having a very large footprint. The footprint is 57 years of the human life of a normal person. And then you spend between $1 and $3 million in training these examples. So are we wasting electric energy, liberating CO2, and spending money just to have bias on these models? And this is the paper that, the famous stochastic parrot paper, but by Emily Bender, Timothy Gebru, Angelina Macmillan Mayer, and Margaret Mitchell, that couldn't write her name because she was still at Google at that time. And remember, Timothy Gebru was fired because of not wanting to take her name out of this paper. And this was published last March. And this is a meta-ethics problem. What happens when the people working in AI ethics in a big company have issues with their work? And later, anyway, Margaret Mitchell also followed the same path, and she was fired in February because of trying to look in her own email about discrimination regarding Timnit's case. So a meta-ethics issue that is really bad. And with a group of colleagues, we wrote this paper, Towards Intellectual Freedom in an AI Ethics Over Community, that is available as part of this new Springer journal on AI and ethics, and you can download it from their site. So let's go now to the second part. So what we want from algorithms. One possibility is this statement that was done in 2017, so it's already like 4 years, on the properties that algorithms should fulfill to be transparent and accountable. So these are the properties. I will not read them, but awareness is a very important one. If you're not aware that you can be biased, that's already a problem. And this problem starts with us. If a person is not aware of their own biases, you will never solve the problem. And systems do not need to be perfect, but seems that for people, they need to be much better than us. So when autonomous car kills a person in Arizona, that was Uber, this was a big news. Any day, a lot of people die because of a car accident. And this is related to something human too. And this new book by Cesar Hidalgo and collaborators that basically explores this problem of how humans judge machines. And they find that basically humans are much harder on machines than humans. So we allow human errors, but we are not allow machine errors, in spite that machines are learning from humans. So this is another thing. So if we are learning from humans, why we want them to be better than us? In the best case, could be the same as us, but of course we want them to be better. And then there are grammatical questions with these properties. So to which part of the system applies, to whom is important, can they be fulfilled simultaneously? Do they make sense together? For example, transparency is something that you ask in Latin America because we don't trust institutions, but accountability is something that is asked say, in the US because institutions are trusted, and they are very different. To demand transparency is very different to wait for accountability. And then here I have a table of 30 different properties of systems, not all of them related to AI, but remember this is not only for AI, this could be for any system. And you see that some things are important for data, some are important for the algorithm, the model itself, some things are important for the system, and some things are important for the governance of the system. And to whom is important? Well, some are important for justice, some are important for the government, like regulation, some are important for users, like user experience, and some are important to society, for example, discrimination. And basically sorting this out, this is my proposed taxonomy of properties. There are 6 main classes, which are awareness, data provenance, completeness, usability, transparency, and responsibility. The ones that are underlined are the ACM original ones. And you see that here there are many more, and they're not exactly at the same level. So this is something I'm still working on before publishing it. And then some people is interested in the governance. For example, this is from a paper by Ben Schneiderman, one of the fathers of HCI. And you see that he has like 3 levels: the team, the organization, the industry. And one question is how we can develop software with the help of AI so that software is much better than current software. There are some also legal and ethical colonialism. So basically the UK, France, Spain, Portugal, and Muslims have exported their way to see the world to the rest of the world. So this is what is called technological humanism. And remember, humanism was behind slavery in the past. So humanism is not that human. And it's just a word used by pale men to basically encode a philosophy. And here you have also some to put an example of Ubuntu. So Ubuntu is a philosophy and ethics from the south of Africa, and basically says, I am because we are. So the focus is in the community and not on the person. And there is a very interesting paper saying that Descartes was wrong because a person is a person through other persons. And the others, so this is important. And the other day I saw these jokes that about COVID says what Descartes will say, all these people that doesn't think but still exist. Next topic, identity, data protection, and privacy. Remember, one thing is to be anonymous. Another thing is to have your data private. Another thing is your privacy as a person. And you know, privacy is a human right. Some people like Carissa Bellis, a very excellent book, Privacy is Power, says that privacy is a collective right, but I believe it's more like you have more like a relational or collective dimension of the right, but still it's just a human right. And this is all related to what are called the neural rights, and I will not go there, but that's also another important aspect. If we start splitting our body in body and brain has different rights than humans that also include the brain. So here you have also different legal ways to see things. For example, one thing is to do everything that's not forbidden, like freedom of expression, versus I can do only what is allowed, like GDPR in the EU. And also you have digital nudging, which is everywhere in the internet. And then here, things like awareness, that you are being nudged, consent or legal basis to do whatever thing people want to do with you, and minimal data collection to achieve your goals and not more, and minimal time to store the data and not forever. So here the Article 22 is very important, that regulates automated decisions by system. And I will not read this, but the important thing is you have the right to contest the decision. So a person has the right to contest the decision. What this means in practice? In practice, it means that if you want to give people information about the processing, you need to have interpretability. If you need to explain the decision, then you have to have explainability. And if you want to make sure that your system works as you are saying it works, then you need to have continuous validation, testing, and maintenance. So here there's an interesting example in France of GDPR in action. They put cameras in a high school, in two high schools in south of France. And the court said that was illegal because they didn't have the competence to decide it. They didn't have the consent of people. And also the solution was not proportional to the goal. Like for security, maybe you just need a person in the door and not a facial recognition by cameras. And one problem here is that these laws are kind of a one-size-fits-all. And that's important, that's complicated, because it means that the same law for all human rights, same law for all domains of application, like health or education, and also for all sizes of companies. It doesn't matter if it's a small store or a multinational. And then you get to regulation. So last year, the US government started antitrust cases against Google and Facebook, and recently also to Amazon. So all the big companies are being targeted. And during Trump's government, there were several trials in 2019, 2020 to start regulating this, and they were not successful. One was even from Kamala Harris, the current vice president. And now things that may happen because lawmakers are introducing antitrust reform that could reshape many multinationals. So another thing important recent that happened here was about 2 months ago in April, the proposal for the EU regulation for AI that should be in place at the end of 2022. And here there are all the things that appear. The most important one are forbidden uses, like, for example, anything that causes physical or psychological harm. And also things like high-risk systems. And here the problem will be to distinguish between low-risk and high-risk systems. So basically, we're putting a continuum of risk in two categories, and that will be a problem for sure. Some cities are registering algorithms, like Amsterdam and Helsinki. Some companies are doing audits, third-party audits or direct audits. And for example, very interesting paper from the auditing algorithms team at Northeastern, where they agree with a hiring company that was using AI, a hiring solution, to publish the audit independent of the result of the audit, So this is a very interesting example of a real audit in a company. There are many bad human practices. I think I'm running out of time, so I will skip this. You can see the video later. But what we can do? So we have problems on how we look at the solutions. We have design and implementation issues. For example, do systems reflect the characteristics of the designers or of the coders? In my past Bias on the Web talk, I was using this example from University of Virginia that basically shows that 19 teams did all different things doing data analysis, but recently in Norway, they showed that one specific problem, the bias of the coders was translated to the code. I think we will see more of this in the future. And then we should check if we're doing the right evaluation, right experiment, right test data, right metrics, and the right baseline. So things we can do, so analyze for biases in the input, recollect more data in the regions that you have less information or the problem is more complex. You need to have the model aware of the biases, and also the user should be aware of all the biases all the time, so the user interface should help them to do this. And of course, in the evaluation, you shouldn't fool yourself and be very hard on yourself to test it. So recommendations, design for people. Remember the limitations of our systems. Don't reproduce the past. Have an ethics board and at least 50% external, otherwise you have a conflict of interest. Enforce the code of ethics. Explainability, more evaluation, and I prefer to talk about humans in control. We are the designers, we are playing God and not having only humans in the loop. And remember, ethics is like privacy in some sense. You have a collective dimension. It depends on the ethics of your providers and also the ethics of your clients. It's not only about you. So to finish, try to be aware of all your biases and also your ethics. It's complicated, and here I finish with one question and one fact. So can AI algorithms ever be ethical? This is a very interesting essay by Hazel Henderson, published this year. And then David Lauer says you cannot have AI ethics without ethics. So I will stop here and to answer questions. Thank you.
Thank you, Ricardo. Do we have any questions in the chat?
We can... Let me see, yeah.
So one question from the audience is, why should we collect customers' detailed data while we are not sure about our security systems? And in any way, if we do, why not utilize blockchain systems? That's, I guess, two questions in one.
Yes. I prefer not to discuss blockchain. We have other issues there, and some of them are ethical, like consumption of electricity. But I think this is a very good question. So today we're collecting data just to predict, for example, user profiles, and this is changing as we speak, because cookies may be gone soon. And we have things like Google pushing for flocks. We have Apple basically now in the last version of iOS, people will basically have to say if opt-in to be tracked or not by every application. So you may say, I don't want to be tracked. And this is creating a problem, because then people will not be able to be profiled. I think in the future, people will have to share, willing to share for some incentive their profiles without losing their anonymity. As I said before, one thing is to be anonymous, another thing is to be private.
Okay. We have a second question. How best can non-computer scientists contribute to the discussion on ethics and AI?
Well, as I said in the presentation, sometimes we are trying to answering questions we shouldn't answer, because we're computer scientists, we're not ethicists or philosophers. So I think that they need to help us to solve the issues, and we need also the field experts in every domain expert to basically give us the solution, in the sense that what the society wants in each of these cases. So, for example, should we use facial recognition? You see that, for example, in the case of the EU regulation that is proposed, this can only be used in public for law enforcement. No one else will be able to use it. If that becomes a rule, that will affect the whole system in the world. So we need help from social sciences and psychologists, ethicists, to come up with the right solution. This is a multidisciplinary problem. No one has all the answers.
I'll add a follow-up. Oh no, we got another question. So I'll let. Actually, I'll add a quick follow-up,
Yes,
and then I'll
please.
ask the audience
Yes.
question. You mentioned it should only be used, for example, the facial recognition data for law
No,
enforcement.
that's what the EU says.
I understand, but even within that use, though, there's plenty of room to kind of commit all the problems you outlined, like bias and
No, of course.
all sorts of issues. So it's not enough just to say this is what you can use it for. It's even within that limited context. How can you use it, and how can you make sure you're not using it in ways that violate the ethics, where you accuse somebody, for example, of a crime that, and they're completely innocent just because there's a match or a mismatch or a failure to match.
Already the civil society is saying that one of the problems is having law enforcement using that, for example, for what you say, accusing someone that something didn't do.
The next question is, and we have 4 more minutes left. Can a predominantly white male team of engineers design an equitable system?
So this is a can. I would say yes, but maybe it's harder if you have a group of female doing it, or a more diverse group where you have many different kinds of say not only ethnically, but also, for example, religion, sexual orientation, and so on. So I think diversity helps to look at different points. And when we go to develop the software, this right to contest the solution, I think we have to apply it in the whole process. So you have the right to contest the design, the right to contest the first prototype, the right to contest the evaluation, and so on. And we have to do that ourselves. So contest ourselves, bringing experts, bringing users, bringing colleagues to see other viewpoints. That it's not that we don't want to have it, it's we don't know them. So basically it's about not knowing everything.
But just to clarify on your answer, Ricardo, you said can, and your answer was yes.
It
I
can,
thought
but
I thought you meant to say it's exceedingly difficult, but I don't know.
Right. It can, but it's not easy. That's
Right.
why,
In fact, some might argue it's impossible, and that you need those biases because no matter how bright you are, you're not going to be able to capture all the nuances and experiences.
Yeah, this is like a theoretical answer. Yeah,
Right.
It can, but in practice, I think you need this diversity and inclusion. That's something we are all pushing here.
Are legal penalties an effective way to reduce bias in AI? Which is the best bias mitigation method? Wow.
Wow, that's a very hard question, and that would be a different topic, a different talk. First, the bias mitigation method depends if you are doing it in the input. Many times we don't know about the bias. For example, in the Deliveroo case, there was no data bias a priori, but then the model learned to be biased. So I think depends on the application, and also depends on which kind of machine learning algorithm are you using. And there's still no survey on that. So it's a very good question, and we need to do like a big picture of that question. We don't have all the answers yet, and we need more research on that for sure.
And this will be our last question, as we're running out of time, from Marianne. Human factors, well, actually, I think it's or human factors professionals, information architects, user experience designers. That was an addition to the prior question, the one of, can a group of white males do an unbiased system? And she's adding that this applies also to human factors professionals, to information architects, to user experience.
Yes. And this another question says how and where should affirmative action take place in AI industries? And maybe some one affirmative action will be to what we are saying. We need to have diverse teams. We need to have more inclusion on our teams. So maybe we should say, okay, forbidden to have only pale male teams. that could be a regulation, but we will be different in every country, and of course the resistance will be different in every country because that's a cultural thing.
Okay, so with that, we have hit the end of our time. Please join me to virtually thank Ricardo for a very interesting talk. Reminder, this talk is part of a series which is Expeditions in Experiential AI, and then we have another series happening in parallel, which is our Distinguished Lecture Series that invites lecturers from outside the university to deliver a distinguished lecture. Our next speaker is?
Next speaker is Dave Lewis. In 2 more weeks, he will talk about e-discovery using AI. And e-discovery is something very important for legal and medical applications.
And David Lewis is a well-known figure in the world of information retrieval. And legal discovery is one of the hot areas of application of information retrieval these days, helping kind of lawyers and litigate and judges litigate and discover evidence, etc.
See you in 2 weeks, right?
Yes, and thank you everyone. Stay tuned for our announcements, and we hope to continue to see you at our future lectures.
And follow us in all social networks.
Yes, please do.